Somewhere in the darkness, more than 1 billion light years from where you're sitting right now, there is a structure so massive that the moment astronomers measured it, they had to check their instruments twice. Not because they thought they'd made a mistake, but because what they were looking at simply should not exist. A single object stretching across a distance so enormous that if you replaced our entire galaxy with a single grain of sand, this thing would be the size of a football field. And at its very center, something even more terrifying. Something that makes the black hole at the heart of the Milky Way look like a pebble next to a mountain. By the end of this video, you'll understand exactly what that means and why it quietly changes everything we thought we knew about the size of the universe. But before we get there, I need to take you back to the beginning, because to truly feel how large this thing is, you first need to understand where we start. Quick question before we dive in. Where are you watching this from right now? Drop your city, your country in the comments. I'm always blown away by how many corners of the planet this channel reaches. Okay, let's go. Start with something you know. You've seen Earth from space, a marble of blue and white, fragile, beautiful, small. You could fit about 1 million Earths inside the sun. That already breaks something in your brain if you really sit with it. 1 million of these inside that. But the sun? The sun is just average. There are stars so large that if one of them swapped places with our sun today, its outer surface would swallow Mars whole. A few would reach Jupiter. Our sun wouldn't even be a noticeable detail. Still, stars are just the beginning. Our sun is one of roughly 200 to 400 billion stars inside the Milky Way, and the Milky Way stretches 100,000 light years from edge to edge. Light moving at 186,000 miles per second would take 100,000 years to cross it. To put that into human terms, modern humans have existed for about 300,000 years. If a beam of light had started crossing our galaxy when the very first humans walked the Earth, it would still be traveling today, and it wouldn't even be done yet. That is the galaxy we call home. And yet, it's not even close to the largest one we know.
Just 2.5 million light years away sits the Andromeda Galaxy, slightly larger than ours, containing perhaps 1 trillion stars. On a clear night, far from city lights, you can actually see it with your naked eye. That faint smudge, that's an entire galaxy. 2 trillion stars in a thumbprint of sky. Now zoom out further. Galaxies don't exist alone. They cluster together. Dozens, hundreds, sometimes thousands of galaxies bound by gravity, slowly orbiting a shared center of mass like a giant invisible drain pulling everything inward. And those clusters gather into superclusters, and superclusters trace out filaments, enormous cosmic threads stretching across billions of light years, forming what astronomers call the cosmic web. If you could see the whole observable universe from outside, it would look like a 3-dimensional spiderweb, glowing knots where clusters meet, long threads connecting them, vast empty voids between. This is the architecture of everything. And within this structure, something extraordinary happens at the most gravitationally powerful locations, the deepest pockets of the web's knots. When a galaxy sits at the exact gravitational center of a massive cluster, it becomes something the universe didn't plan but couldn't prevent. A collector. Over billions of years, smaller galaxies drift inward. They can't escape the gravity well. They get close enough and they're torn apart, their stars stripped away, their gas absorbed, their core swallowed, one by one, merger after merger, over hundreds of millions of years each time. Astronomers call this galactic cannibalism. It sounds violent, and it is, just on a timescale so vast that calling it slow doesn't even begin to cover it. Every merger destroys structure. Spiral arms are dissolved. Order becomes chaos, and chaos, given enough time, settles into something smooth, something rounded, something enormous. This is how the universe builds its giants. And somewhere in that process, at one particular location in a galaxy cluster more than 1 billion light-years away, it built something that left astronomers speechless. In the constellation Virgo, there is a galaxy cluster called Abell 2029. To a casual telescope, it looks like a crowded patch of faint lights, dozens of galaxies packed together, all orbiting a shared gravitational center. But right at that center, something sits that doesn't look dramatic at first glance. It appears as a dim, slightly fuzzy oval of light. Nothing that would stop you in your tracks, nothing that screams record-breaking. Astronomers cataloged it simply as IC 1101. And then they measured it. IC 1101 stretches between 4 and 6 million light-years from edge to edge. Our Milky Way is 100,000 light-years wide. This galaxy is 40 to 60 times larger in diameter. If you shrank our galaxy down to the size of a coin, this one would span the length of a large room. If IC 1101 were placed where the Milky Way sits right now, it wouldn't just swallow our galaxy, it would also engulf Andromeda, our nearest large galactic neighbor. The entire local group, dozens of galaxies spread across millions of light-years, would fit inside its structure with room to spare. Let that settle. Every galaxy you can see on a clear night, every galaxy humans have ever pointed a telescope at in our neighborhood of space, all of it inside one galaxy. And the star count? The Milky Way contains somewhere between 200 and 400 billion stars. IC 1101 is estimated to contain around 100 trillion. If you tried to count every star in IC 1101, one per second, no breaks, no sleep, no stopping, it would take over 3 million years. 3 million years ago, our ancestors were just beginning to walk upright. Now here's the part that genuinely unsettles astronomers. All of that light, every photon reaching our telescopes from IC 1101, left that galaxy more than 1 billion years ago. We are not seeing it as it exists today. We're seeing it as it was when Earth was still in its early chapters, when life here was microscopic, when nothing on this planet had yet developed eyes to see anything at all. Those ancient photons were already mid-journey. And here's the question no one can answer. What does IC 1101 look like right now? We can't know. That information hasn't reached us yet. It won't for another 1 billion years. Whatever has happened there since, new mergers, new bursts of activity, new changes, is traveling toward us at the speed of light, and we simply have to wait. Astronomy, in that sense, is cosmic archaeology. We reconstruct ancient history from ancient light. IC 1101 is an elliptical galaxy. No graceful spiral arms, no flat rotating disk, just a smooth, rounded structure filled mostly with old red stars, the stellar elders of the universe, still burning but no longer young. Star formation has nearly stopped. The cold gas required to birth new stars has largely been used up or heated beyond the point where it can collapse. The era of explosive growth is over. This is a galaxy in the late chapters of its life. Massive, quiet, ancient. And at its very center, here it is, the moment I told you about at the beginning, sits a black hole so extreme that comparing it to the one in our own galaxy almost seems unfair. The Milky Way's central black hole, Sagittarius A, weighs about 4 million times the mass of our Sun. That already sounds enormous. 4 million suns compressed into a region smaller than our solar system. The black hole at the center of IC 1001 is estimated to contain between 40 and 100 billion solar masses. If Sagittarius A were the size of a coin, this one would be a mountain. If it replaced our Sun, its event horizon, the boundary beyond which nothing can escape, not even light, would extend far beyond the orbit of Pluto. Every planet in our solar system would be inside it. There would be no solar system, just a ring of no return. And it didn't start that way. Like the galaxy itself, this black hole grew through mergers. Every time IC-101 absorbed another galaxy, that galaxy's own central black hole was pulled inward. They would orbit each other, a binary system slowly spiraling closer, radiating energy as gravitational waves, ripples in the fabric of space-time, until finally they merged into something larger. This process likely happened dozens of times. Each collision produced bursts of energy brighter than entire galaxies. Jets of high-energy particles were launched into space at nearly the speed of light, carving enormous cavities into the surrounding gas of the cluster. The evidence of those ancient outbursts is still visible today, massive bubbles in the hot gas surrounding the galaxy. But now, it's quiet. The feeding frenzy is over. The black hole sits at the center like a dormant volcano. Still dominant, still gravitationally absolute, but resting. Here's the thing about IC-1001 that doesn't get said enough. What you can see, the trillion stars, the ancient light, the monstrous black hole, is only a fraction of what's actually there. Most of the mass holding this galaxy together is invisible. Astronomers call it dark matter. It doesn't glow, it doesn't absorb light, it doesn't reflect it. If you stared directly at it, you would see nothing. And yet, without it, galaxies like IC-1001 simply could not hold together at the scale we observe. Stars at the edges of galaxies orbit faster than they should based on visible mass alone. Something unseen is adding extra gravity. In typical spiral galaxies, dark matter makes up roughly 85 to 90% of total mass. The visible stars, everything glowing, are just the surface details. Now, scale that up. IC-1001 sits inside a dark matter halo that may extend tens of millions of light years beyond its visible edge. The luminous galaxy is only the bright core of something far larger and completely invisible. When you account for everything, visible stars, gas, the central black hole, and the surrounding dark matter structure, the total mass of this system may reach hundreds of trillions of solar masses. That is not just a galaxy. That is a gravitational titan wrapped in a cloak we can't yet see. And here's the most quietly profound part of all of this. IC-1001 is not an accident. It is not an exception to the rules of physics. It is those rules taken to their logical conclusion. The same gravity pulling an apple toward the ground pulled hundreds of galaxies toward one point in space over billions of years. The same atomic physics powering our sun powers its 100 trillion stars. The same carbon, oxygen, and iron found in your body exist in the distant stars of IC-1001. There are no special laws for the enormous and different ones for the small. The universe scales upward using the same blueprint, and at the far end of that blueprint, this is what it builds. IC-1101 will not last forever. Over tens of billions of years, its remaining stars will burn out one by one. Star formation will eventually cease entirely across the universe. The galaxy will slowly dim, not dramatically, not in a single flash, but in a long, quiet fading. The central black hole will outlast every star, but even it is not eternal. According to quantum physics, black holes slowly lose energy through a process called Hawking radiation. Over timescales so incomprehensibly vast that they make the current age of the universe look like an afternoon, even this titan will eventually evaporate. The largest galaxy we have ever discovered will, one day, be gone. We live in a remarkable window of cosmic time. Galaxies still glow. Clusters are still visible across billions of light years. The universe is still lit up enough for us to see its largest structures. On a small rocky planet orbiting an ordinary star in a mid-sized spiral galaxy, a species evolved that could ask questions. We built telescopes. We decoded light. We learned to read the universe's history in photons that traveled for over 1 billion years before landing in our instruments. And from that ancient light, we reconstructed something millions of light years wide.
That is not small. That is extraordinary. When we measure the biggest galaxy ever discovered, the universe is, in a very real sense, measuring itself. So, the next time you look up at the night sky and see that faint, hazy band arcing overhead, our galaxy, remember, somewhere out there, more than 1 billion light years away, there is a structure so enormous that our entire galactic neighborhood fits inside it without touching the edges. And we found it, we measured it, we understood it. Not because we're large, but because somehow we learned to think that big. If this video gave you that feeling, that quiet sense of being small and amazed at the same time, leave a like. It genuinely helps more people find this. Subscribe if you want more of these, and drop in the comments, what's the most mind-bending thing from this video for you? I read every single one. See you in the next one.